Hello, Algebra 2. Today we're going to talk about 1.6, solving linear inequalities. So first of all, if you're looking at the table up in the right-hand corner, remembering what our inequalities are. So not equals kind of is what we're dealing with here. So it can be less than, greater than, less than or equal to, or greater than or equal to. Keep in mind that both of these or equal to's, they're or statements because obviously you can't be less than a number and equal to the number at the same time. Also keep in mind that these inequalities can be read going both ways. So if I said, well, if I wrote this, reading this left to right, this reads 3 is less than 6. But I can read this going from right to left, and it's 6 is greater than 3. So they can be read going either way. Typically we read going left to right though, so just make sure that you can read those symbols. So a linear inequality is a linear mathematical statement that contains an inequality. So when we say linear, we mean there's no exponents in there. Okay? It's going to be something in the form like ax plus b maybe is less than c. It could be whatever inequality that you want it to be there. So that would be, though, an example of a linear inequality. So the solution to this linear inequality is going to be an inequality that works as an answer. So for instance, if we said 3x is less than 6, we'll go ahead and if we solve this for 3, and so you solve it really just like you solve a regular equation, except for one thing I'll remind you here in a second. So x is less than 2, that is my solution. So the difference between a solution to an equation and a solution to an inequality, this is a range of answers. This is everything less than 2. Where if you were to solve the equation 3x equals 6, that's just one answer. So this is a range of answers. And that is what your solution is that range of answers that will work. And sometimes it might only be one number, but most of the time it's going to be, an entire range to one of the infinities. Graphs for these, we're going to graph them on a number line. Okay, and on our number line, remember we put arrows on the ends. So if I want to graph this x is less than 2, I'm going to go 1, 2, 3 because that's my one number on either side. Okay, so we're going to do an open circle for less than or greater than, and we're going to do a closed circle for less than or equal to or greater than or equal to. So this is going to be an open circle on 2, and then you draw an arrow. And I want my x to be every number less than 2, so I'm going to go to the left because that takes care of every number that is less than 2. All right, let's do an example and solve another one here. So just like an equation, you want to get your variables on the same side, and I would do that first. Okay, so I'm going to go ahead and subtract 7x from both sides, which is going to leave me with 9 greater than or equal to 3x minus 12. And so you do the same steps, then I want to get rid of the 12, so I'm going to add the 12. 21 is greater than or equal to 3x. I'm going to divide by 3 to get x by itself, so I get 7 is greater than or equal to x. Or you can flip it and write it x less than or equal to 7. Notice I flipped the inequality also. The less than part is here by the x. The less than part is still there by the x. Now one thing to point out, let's look at x is less, or 3 is less than 6. If I add the same number to both sides, does that remain true? So I can add the same number to both sides. Can I subtract the same number from both sides? I'm going to go back to where I just came from. I can. That remains true. Can I multiply both sides by the same number? Okay, that remains true. And if I divide, we're going to get back to where we came from. That remains true. But we got to look at one more here. Actually, we could look at two. What if I multiplied by a negative number? So I'm multiplying by a negative number. I get negative 6 is less than negative 12. Is negative 6 less than negative 12? It's not. If you're thinking about it on a number line, if that's 0, there's negative 6, down here is negative 12. Negative 6 is not less than negative 12. That's false. So how do we fix that? Well, we're going to fix that by switching our inequality. So we need to write down when multiplying or dividing by a negative number, reverse the inequality. So this is very important. This is your only rule that is different from solving an equation. So only when you multiply or divide by negative, you reverse your inequality. All right, the last thing we need to talk about are compound inequalities, and these are inequalities that have an and or an or. So and statements, it needs to be in both. So you're looking for the overlap. So for instance, if you graphed x is greater than 1 and you graphed x is less than or equal to 3, where do they overlap? So they overlap here, okay? So then your answer, and you can just graph what you want here. Let's still do 1, 2, 3, 4, open circle on 1, closed circle on 3. You just need that part of the graph, and that would be 1 less than x less than or equal to 3. So that is read either the way I just did, 1 less than x less than or equal to 3, or x is greater than 1 and x is less than or equal to 3. This is how and statement answers should look. Okay. Ors, you're looking for the union, and the union is just everything everywhere. So anything that's in one or the other or both. So for instance, if you have one maybe that goes this way, x is less than 2 or x is less than 4, then that's your graph. It's just anything, anywhere. So x is less than 2 or, and you just write the word or in there, x is greater than 4. And we're going to look at two examples of these real quick. All right, first of all, here we have an example of an and we know this is an and because the only ones that are written like this are ands, okay? And what I want you to notice is that there's really three sides. So here we have the left side, the middle, and the right side. And so if you want to solve for t, you want to get t by itself, whatever operation you do, just do to all three sides. So if I want t by itself, I need to get rid of this 4, so I'm going to subtract 4. And I'm just going to subtract 4 from all three sides. So I have negative 13 less than t less than 6. And there's your answer. If you're going to graph this, and for the sake of time here, you're going to do all these numbers, write them all out. Let's see here. There's 0. There's 6, went to 7 there. Alright, so neither of these are equal to, so it's an open circle on 13 and an open circle on 6, and your line just goes between them. So this is all of those numbers between 13 and 6. Our other example here is an OR, so you have two separate inequalities. You just solve both inequalities. So I'm going to subtract 9 just like you would an equation. Divide by 6. Remember, unless you multiply or divide by a negative, you just do it exactly like you would an equation. So we get 3x, that's a plus, 21 divided by x is greater than 7. So this is your answer. It has an OR in the middle of it. Okay, I'm going to graph it. So x is less than -1, so that's an open circle on -1 with an arrow to the left for less than -1. Or x is greater than 7, that's an open circle on 7 with an arrow to the right. Okay, I know that's a lot of information, but hopefully it's all review. If you have questions, let me know, and we'll see you in class.